Welcome back. I'm just going to take you through the next section now on finding measures of spread, or measures of dispersion. You'll find the textbook calls it. So basically, so far we looked at measures of middle, like where's the middle of my data set. Once we've sorted that data set, from smallest to largest and created what's called an ordered array, where's the middle? And there's three different ways we can find the middle: average, or mean, median, and mode. Now, I'll talk about this more in detail in class. The mean is also subject to high values or low values. It can be artificially high or artificially low. So you have to have a close look at your data set. You might ask the question, how do you choose between them? So when artificially high or low values are thrown in, it can distort the mean or the average, and that's not a good thing. So that's when you generally go for an alternate measure of middle, like the median or the mode. Median is quite useful because you can find the middle of a data set that's been ordered as an ordered array from smallest to largest, and that would be the true middle. And the mode's quite good when you got repetition or frequencies recurring of particular numbers. Now you'll notice if you look at the REWA site or realestate.com for house prices, they use the median house price in a suburb, because typically when you look at some suburbs, you've got some very expensive houses that can artificially drag up the average house price. And on the contrary to that, you can also have some very cheap houses that can drag down the average price. So you've got to be considering these things, and that's why they choose the median. Okay. Now, in terms of measures of spread, though, or dispersion, we can look at things like variance, standard deviation, and the coefficient of variation. And then we can ask questions along the way and say, is the data skewed? Or are there any outliers? That type of thing. So the variance is actually quite easy to calculate. You can see the formula on the right here. It equals VAR, and you'll notice the formulas come up. You can simply double click on the one with the S for sample, because this is a sample data set, not a P for population data set. So we can highlight those data, or that data set in yellow, and hit enter, and there's the variance. Now again, the variance is how spread out your data set is. It's actually a percentage squared, the variance. So it's not an easy thing to interpret. So what you find in most textbooks is they get you to calculate the variance so that you can then calculate the standard deviation, which makes it easier to interpret the spread or dispersion of your data set. And to be honest, the actual standard deviation is simply the square root of the variance. So you could go equals SQRT for square root and click on the actual variance and hit enter, and that would give me the standard deviation. Or alternatively, you can actually use the formula you see, ST DEV, and the one with the S for sample, double click and highlight the data set in yellow and enter, and you'll notice you get the same value. So you can either do the square root of the variance, or you can use stdev.s for sample as opposed to .p for population data. So now, how do you interpret the standard deviation? Well, generally what we do, we look at the standard deviation as a plus or minus value in terms of distance away from the middle in terms of the mean. So, for instance, I could look at the mean up here, which is 33.11, or the average, and if I add the standard deviation of 13.14, you can get roughly 36.25. And so you can say, okay, generally when you're looking at plus or minus one standard deviation from the mean, so if I subtract 13.14 away from the mean in the same way, it takes me down to around 20. So basically we're looking at 20, up to 46.25 or 46 roughly. 20 to 46 should contain roughly 65% of all the data values. And this is assuming normality in the data set. Now, so standard deviation is quite useful in that sense. And we could say that plus or minus 2 standard deviations in general from the middle would incorporate roughly, they say 97.25 or 97.65, depending on what textbook you look at, percent of the data set. And plus or minus 3 standard deviations basically would actually give you 99+% of the actual data set values contained within those limits. Okay, I'll explain more of this in class on the whiteboard so you can see how it works, but it's actually quite useful in that sense. The next one is the coefficient of variation, and this is what we call an absolute or relative measure of dispersion or relative measure of spread. Very useful for comparing multiple samples. So if you've got multiple samples you're trying to do direct comparisons with, then you can see which one's got more variability as a result. So, for instance, if I go equals, how do we do it? you can see the formula on the right is the standard deviation, which is the one we just calculated. So you can click on that, divided by the mean, which we've also calculated. And that's it. So if we close the brackets, now you should get a decimal solution, and then we can turn it into a percentage. Oh, that's right. I already formatted my cell as a percentage. But if it comes up as a decimal, after you've got this answer, just click on the percent symbol here, and that will actually convert it to a percentage. So it looks like there's 39.68% variation in terms of the standard deviation to the average or mean. So that gives you an idea of relative dispersion or relative spread. Again, have a look in the textbook. It does talk about the coefficient of variation in the chapter readings as well. Remember, I'm expecting you to be reading these chapters along the way as we progress through the different sessions over the weeks. Okay. Again, I'll talk about this more in class as well, just to give you some direct feedback and show you some relevance. I'm just showing you pretty much how to do it in Excel at this stage. Now, is the data skewed? Now, skewed means is it stretched like a tree when you stretch it to the left or stretch it to the right? Then we talk about whether it's left skewed or right skewed. If we stretch it to the left, it's also known as negative skewness because it goes in terms of a number line. The numbers go to the left on a number line from 0 to the left are negative, whereas the numbers from 0 to the right are positive. So we actually talk about it being negatively skewed when it's skewed to the left, or positively skewed when it's skewed to the right. When there's no skewness at all, and we say it's symmetrical. So that's how we sort of talk about it. And again, I'll show you some slides in the PowerPoint slides on how to view this in a pictorial sense and interpret it. So the easy way of doing it, is it skewed or not, is quite simple actually. The rough rule of thumb is if the average is greater than the median, it's skewed to the right or positively skewed. If the average is less than the median, it's skewed to the left or negatively skewed. So when we look at our average and our median, quite clearly you can see the average is greater than the median. The average is 33.11 and median is 27. So the average is a bit greater. When it's greater, it's skewed to the right or positively skewed. And I'll show you what the shape of the distribution looks like in the slides during class time. So we say, yes, it's right skewed. Next question, are there any outliers? This is where I'm going to go to the next section using the Z-score and the standard normal distribution to actually standardize our data and do direct comparisons and use probability. So it kind of feeds into the next week's topic as well. So I'm giving you an early introduction to it. So I'll stop here and I'll come back and show you how to do the calculations for the Z-score.